Yagna, tell me if we are live now. We will begin. Perfect. So yes, welcome everyone. Pritika, you can begin.
Okay. A very good afternoon to one and all connected here. I am Pritika Murugeshan, Head Event Coordinator, and on behalf of Center for Green Technology, I'm greatly pleased to welcome you all to the 6th edition of Innovative Practices of Green Technology, organized by the Center for Green Technology, Institute of Chemical Technology, ICT, Mumbai, under the leadership of Professor Aniruddha B. Pandit, Vice Chancellor, Institute of Chemical Technology, and Professor Prakash D. Vaidya, Coordinator of Green Technology, Institute of Chemical Technology, ICT. Today, Team IPGT takes immense pleasure and privilege to witness the presence of our esteemed guests, Dr. Dietmar Huglin, Mr. Ramakrishnan Mukundan, and Mr. Adnan Ahmed at our webinar. Good afternoon, one and all. Starting with the session, Innovative Practices of Green Technology, IPGT, is an initiative to inculcate the importance of sustainable and green practices in industrial processes. It is an initiative taken by the Center for Green Technology at the Institute of Chemical Technology, which is a student-run organization and aims to provide a platform for the exchange of technical views and information from the industrialist, academia, and the students in the domains of green technology and sustainability. Without any further ado, we would now start our session with the introduction of Dr. Dietmar Huglin. Dr. Huglin is the director of BASF's Innovation Campus Mumbai and vice president for Advanced Materials and Systems Research. He holds a diploma in chemistry and a PhD in natural sciences, both from University of Freiburg im Breisgau, Germany. In his 30 years of research career, he has held several senior management positions in Germany and Switzerland, which include Global R&D Head of Segment, Home and Personal Care, Ciba Specialty Chemicals in Grenzach, Germany, and Head of BASF's Research Center, Basel, Switzerland. Example for key products from his own research work are photopolymerides for semiconductors, developed for OCG Providence, Rhode Island, USA, and cosmetic UV absorbers. Both core innovations have reached worldwide acceptance in their respective markets. Dr. Huglin is the key author of 45 US patents and numerous written and oral papers. For his contributions to progress in applied chemical sciences, he received the Sandman Award for the Swiss Chemical Society 2004 and the BASF Innovation Award 2011 and the BASF Business Excellence Award 2013. It is indeed our greatest honor to witness your presence at IPGT, sir. Surely your professional outputs and experience will certainly enlighten us and leave a mark in our minds. Viewers are requested to submit their questions via live chat option in the YouTube live session. We are noting them down and will ask them by the end of this session. Sir, you may please begin your talk.
Yeah, thank you for the kind introduction. I hope everybody can see the screen. It's a pleasure for me to give this talk today, and I will do my best also to keep in time. Sustainability and green chemistry, this is the mega topic in our industry, and it will remain the mega topic for the century, I'm quite sure. It's a huge field of discussions. I want to give you an overview how BSF looks at it, but also giving a few examples where we work at. So already I got introduced. I will get a little background to me. So I'm Dietmar. In Indian, you would write D-E-E, not D-I-E. I'm a German living in Switzerland, and Basel is basically a capital of the chemistry. You know, Clariant, my colleague who comes later, the headquarters of Clariant is close there. Then we have Roche, we have Novartis, we have Lonza. It's an industrial city for chemistry and pharmaceutical chemistry. I did my PhD in Freiburg, close by, 60 kilometers away in Germany, the Black Forest University. And I spent so far 30 years in industry in very different functions, but everything was always close to research and development. And I had the privilege to work in different countries, also now in India. And the main achievements you have shown, I'm proud. And I also was lucky, of course, to develop products which leave a trace also in the market and which are quite important right now. My special relation with India is long, because I had the first trip in 1993 as a chemist in former Ciba-Geigy, and we had a campus in Goregaon here in Mumbai. And I had the privilege over the last 27 years to see many places and to have many meetings. And since 2018, I'm resident here in India. Yeah, a few words. I have to say this because here I'm in India. I'm from Basel. You know, this is my hometown. And as I said, it's a medieval town. And it's a kind of a hub of pharmaceutical chemistry and chemistry. So many also small companies now there. And it's also, in a way, a hub in sustainability because a lot of companies also deal with this topic. My alma mater also I would like to mention because it's an important year now, 2020, you will see. This is Freiburg im Breisgau, old city and with important German university. Why is it important? Of course, many innovations come from Freiburg. It's a lively, it's a really a young city, innovative city. I want to give you two examples for this. And one is, 100 years ago, Hermann Staudinger, he gave the first description of macromolecules. This is exactly 100 years ago, and this is now celebrated also in Freiburg, where he did these discoveries. And you know that polymers later became a huge field and has changed our whole life after Second World War. And then this may not be known so well. Freiburg also is the place where America, United States of America, or the continent America got the name America, because there was a map maker very famous at his time. And 1507, he was in contact with the discoverers, with the sailors who looked at the places there. And he honored his close friend, Amerigo Vespucci, an Italian sailor, and gave the name America. You see here on the map that the spot he named America, this would be now South America, but this has then been taken for the whole new continent. Yeah, now I give a brief overview. I introduced to BSF briefly. I will show you the BSF's way to address sustainability. Some basic chemical processes. As you know, BSF is very broad and deep. We come from raw materials, we go downstream to specialized product offerings. Of course, a lot of energy, a lot of raw materials go into basic chemical processes. Then I will briefly elaborate on the green principles which we apply at BSF. The concept of circular economy is extremely important for India, for the world, also for BSF, and I will close then with the chemical recycling, which is part of the circular economy. Yeah, I think all of you, if you are chemists or so, you know BSF, it's a very big company, sometimes difficult to understand everything what's going on. We are basically in all markets, world markets, and we have a little more than 1 lakh employees. And for us, India is an important place to be. One important topic, I come back to this later, is Verbund. This is a German word which is difficult to translate. We have 6 Verbund sites, and these are mega sites which contain of a lot of individual plants which are interconnected. This originally has been developed for economic reasons, purely economic reasons, but also, of course, it's important in terms of sustainability, because such a Verbund site has much more potential to really apply also green principles and green chemistry, since it can make use of energy and raw materials in a better way. So the whole structure of the company has changed in the last years and the last decades. This is right now the what we call the 6 business segments, and you see on the left side, this is the big plants. This is chemicals, petrochemicals, intermediates, where we start from oil and gas and come up with alcohols and aldehydes and amines, everything you know as building blocks for chemicals. And we go on with materials. We have industrial solutions,
Hello,
surface.
sir.
Yes, please.
Sorry to interrupt, but I think the slides are not changing. Can you click on the next slide and next slide?
1 second. I go again in the sharing mode. Yeah, give me a second.
Can you click on next slide, one?
Can you see it now?
Yes. Can you click on next slide?
Yeah, but give me a second. This is something is wrong here. Oh no.
Okay, don't worry about it. It's okay. Is it not changing now?
No, it's not changing. Just give me a second.
Okay, now follow as I say, sir. Now first stop sharing.
Yeah.
And then now go on present now. First you stop share. Yeah, now click on present now. And then click on share your entire screen. Then click on share entire screen.
Entire screen, yes. Okay.
Yes. And then click on share and then hit share. Now go to your presentation.
Okay.
And then make it.
Yeah. Can you see the screen now?
I think you have not clicked on present the share screen. You have not shared the screen yet, sir. You go back to the screen.
Yeah.
Then your entire screen. Present now. And then click on your entire screen. And then after clicking on,
I cannot push the share here. I can only put cancelled. Can you see me now? My screen.
No, what I'm asking is that we have to click on that that box which comes after the share button. Do you want me to show it, sir? I mean,
No, I can only click cancel. It's already shared. It tells me that it's shared. Let me again look at it. Now I can share. Now I share.
Yes, now it is sharing.
Can you see this now?
Just a second, it is loading, I think so. Yes.
Can you see this?
Yes. Now
Can you see now in presentation mode? Can you see now in presentation mode? Yeah.
It might be loading. Just wait a second. Yeah. Yes. Now, can you so, simply go next slide and come back? We can begin then.
Can I start from here again? I was.
This is it. Okay. Yeah. This is perfect. Now we can go continue. Yes. Thank you.
Is this now the right thing? Wait a second. Yeah. Okay. Yeah. I continue here. Okay, this is what I said. So we have a very broad portfolio, and this means that if it comes to sustainability on one end, on the fundamental raw material, it's more about process. innovation in terms of sustainability, looking at different feedstocks, looking to on the carbon footprint, all these things. And if we come down, nutrition and care, agricultural solutions, surface technology, this is more about the product offerings we have to make them more sustainable. We really believe in the future of chemistry, and therefore we believe that you students at ICT do the right thing to study chemical engineering chemistry, because chemistry has been always an enabler for the needs of the future, and this will continue like this, because you see here the big trends, and this will be necessary to address these issues of growth of population, but also all the energy questions, more food needed, health, and so on and so on. These are exactly the segments where we are working in. BASF has always redefined itself. You see here, we are 155 years old, and we started with the so-called dye-stuff period. As most chemical companies, we went from there in the fertilizer age, then from there plastics and foams, healthcare, nutrition, and now we call it more systems. We offer complete system solutions, like solutions for electromobility. And this will continue. A company like BASF, but also our competitors, Dow or Clariant or DuPont and so on, they always have to reinvent themselves. Maybe one point, if you look at BASF, one of the dots I just showed you before is related to this big issue. You see the big issue of population growth over the last 350 years, and the prediction until 2050, you see, we started with below 1 billion, and now we are at 7 billion, and we will expect to go up to 9 or to 10 billion in some years. I always ask the students, what is the reason that it happened in the 20th century? This huge increase, look at this. We had between 1960 and 1974, only in 14 years, 1 billion more. Now, luckily, it's flattening slowly, but this is a huge thing. And students normally say it relates to pharmaceutical research. It's true, but it's not the real reason for this huge increase, because this is more about life expectancy. The real reason for this, that this happened in our world, is really BASF. We can say this, because the reason is this reaction, nitrogen to ammonia, and this of course is now a high volume industrial process which brings us the fertilizers, the ammonia fertilizers, and this is a reaction which on industrial scale has been developed by BASF here in joint collaboration at that time with the University of Karlsruhe, one of the early examples of industry and academia successful collaboration, the Haber-Bosch process. We got the Nobel Prize. The project was called Bread from Air, and there's still this column on the right-hand side in the park in front of one of the main buildings of BASF, honoring this huge achievement, which is very important still and also in the future. Yeah, I said innovation for us is really the key for our future. We have to differentiate in future. We will differentiate in future. And BASF spends quite a significant amount of money to innovate, 2 billion euros. And roughly 1/10 of our people, this is 11,000, are working in the field of R&D. 1,000 patents. This is the categories we are dealing with. And here in Mumbai, this is in red. You see Mumbai, this is, I have written in red, this is called Innovation Campus. A campus is a strategic research site which is quite broad in its strategic approach. Shanghai is our brother site. It's a larger site compared to campus, but also of high strategic importance. And then we have also other sites, smaller sites like Suwon or Amagasaki. These are more focused on certain individual technologies like battery technology or so. And the master side, of course, is Ludwigshafen in Germany. And here view, my site here in Mumbai is in Turbe, in Navi Mumbai, just opposite of the train station. It's a very modern site. And if you have time and if COVID is over, I really gladly invite you also to visit our site. It's a very nice place. Yeah, and just to end the introduction on BSF, it's a site where we mainly do synthesis and process development for crop protection, especially chemicals, molecular modeling, analytics. We also do some development for Indian customers. We have a patent group, and we have a space for 300 people, and we are still not 100% full. And the site is now 3.5 years old. Why are we in the Indian market? It's for 3 reasons. Basically, it's about talent, mainly. We have a lot of talent here in India in the interesting fields. And we have technology in India, and we know there are world-class academia like IITs, IISc, NCL, but also ICT. We really like to work with you. And on the other side, of course, we see the market opportunities in India as the 3rd largest economy, a chemical industry here in Asia. So that's a very important factors for us to be present in India with quite a large R&D setup. Yeah, and this brings me now to the topic. Also, why do we conduct R&D in India? You know, we have in India a situation where all the challenges, but also the opportunities with respect to sustainability, clean energy, waste treatment, infrastructure, health and nutrition, everything what I mentioned before on my slides on the future of chemistry, all this is existing everywhere in the world, of course. We have to look for better mobility and looking for better generation of energy, sustainable chemical processes. But in India, we see it little like with a magnifier. So it's a good place to do also such type of activities in the country where we have these topics and where also society needs to solve these topics in a short period of time. How do we address sustainability? First, it's written in our purpose. This is not just a marketing gimmick or nice to mention, a fashion or something like this. This is now at the core. It's our purpose. We create chemistry for a sustainable future. This is our mantra of our company globally at every place where we operate. And we see sustainability in the following way. You see the big circle is sustainability, a very holistic thing. You know, in the past, it was more about to look for economic processes, low-cost processes, getting rid of waste in best possible way. Now, also, its sustainability is, our license to operate at many places. It's also more and more consumer expectation that processes are sustainable, and it's a huge business opportunity in the meantime. The companies who are able to transform into their business into sustainable businesses based on sustainable green chemistry, they will survive, they will succeed, and the others, they will pass away. And if we then go to our different faculties, it's very much about the question of sustainable energy consumption, to produce energy and to use energy in a sustainable way. Water consumption is a big topic. The question of feedstock, getting away more and more from oil and gas, and the mega topic is decarbonization, to reduce the carbon footprint of our industry, which quite significantly contributes to total carbon footprint. And then you see 2 other circles here in the big one, and sustainability. So part of the whole story is circular economy. I come to this. And a part of circular economy is chemical recycling. I will also come to this later. So it's important to understand that sustainability by nature is a comprehensive approach, and it is long-term oriented, as I said, for economic, social, and environmental value. And it is in the meantime as such a matter of humanity's survival. This in the last couple of decades, it became clear. The Club of Rome already mentioned it in 1970, but now it is clear. You saw, maybe you know, the Earth Overshoot Day. This is a calculated day when basically everything what we are doing on this planet is looked at in a way, can we continue or not? And now this year it's August 22, when basically the normal resources were, the sustainable resources were expired. And now we live on credit, we live on credit, but we have to pay back at some point in time. Last year it was in July 29th. It's now in August. Simply, this is an effect of Corona. And if you look at the global thing, it's amazing, and therefore India plays an important role. You see on the left-hand side that only 4 countries basically contribute to the half of the world's footprint China, US, India, and Russia. The other half is all other countries. But if you look on the right side, how many Earths we need, if we would copy the behavior of the different states we see, then India looks very good, because India, if everybody would live like the average Indian, we would still be fine. If everybody would live as the average US person, we would need 5 planets, and in average right now, we live like we are using up now 1.6 planets. Yeah, I come a little to BSF. When we talk about opportunities on green, of course, we have to look where are the big opportunities. And the big opportunities are important for society, for sustainability, but they're also important for an economic view. From a product point of view, a very important topic for BSF and for many of our competitors is the question of change of mobility, electrification of mobility. Why is this so important? You see on the left-hand side the CO2 targets giving in different jurisdictions. It's going down and down and down and down. So we have to get away from combustion engine. The age will come now to an end. The question is, when will it be over? It will be substituted step by step by electrical cars. Norway is now the country most advanced, a small economy, but it will come now also to European, Tesla, Japan, US, and so on and so on. So this is a very important point. On the right-hand side, you see also in future the cars will be more computers on wheels. Less this will change also, digitalization. What is BASF doing here? And I said we are now building up quite huge plants in Europe, if you look at the news, to be able to produce large quantity of battery materials. BASF will not sell cars, and we also will not sell complete batteries, but we sell materials to the battery manufacturers, and you have many types of materials in a battery. The most important one is what is called CAM. You see, cathode active materials, because this is the place where the energy basically is stored in the battery. This is also related to really challenging technology question regarding long-lasting, regarding capacity. But it's also important to understand that an electrical vehicle is not only about a battery on wheels. It also has to change a lot of other features. You see a few here on this slide, because we need to adapt to the new way. The electrical car has different features, and we need to basically refurbish all the systems around the engine, the electrical engine, and this is also, of course, a very important part of our development activities. Yeah, I come now to what I said at the beginning. BASF is both a producer of high volume, large fundamental building blocks, chemicals, which then go into all products, until we come to a mobile phone, which also has chemicals inside, pharmaceuticals, whatsoever. And this, of course, is a very challenging topic, because traditionally these basic chemical processes are processes which are petrochemical based, and also based, as you will see, on quite a lot of CO2 emissions. In this graph, you see on the top graph, you see the carbon, the greenhouse gases, GHG, and most of it is CO2 related, but we also have methane and some others, N2O, for instance. You see that the world is increasing. We have 90, 100 scale, and we hope that we get into a maximum soon. And assume the policy shift, of course, that we disadvantage processes and so on, which are based on fuel. This will come down. Now, the chemical industry, which so strongly depends on fossil fuel, and which also increases the output each year. So it's a little surprising if you look at the BASF curve starting 1990 on a 100 scale, BASF on 40 million 1990, but we were able to bring down the emissions significantly. But now comes the point where we also now heavily, this was mostly done by efficiency optimization of existing processes, but now we have done a pledge to keep the carbon footprint constant until 2030, and we work now heavily on replacement of processes. This has to do with, as you may know, CO2 to fuel. You can use CO2 as a building block for making methane, and from methane you go up to the chain, or you go, for instance, for other type of transformation, CO2 capturing processes, making polymers out of CO2. That's a lot of possibilities. And this is our largest investment right now in processes is related to this issue, because if we do not come up with completely new technologies, we cannot hold it flat, or we have to stop doing some businesses. Yeah. I mentioned the Faboon. This is a picture of our Ludwigshafen site, which is 10 kilometers long and 3 kilometers wide. It's a connection of thousands of plants. And of course, here we have the possibility to optimize also general feedstocks and general core components of this multi-plant setup. And this we do right now. This is a lot of work, a lot of investment. And you see, we do not only have Ludwigshafen, we have 5 other plants of such type around the world. Here in Asia, it's Nanjing in China and Guangdong in Malaysia. And then we have Antwerp in Europe as a second one, and 2 places in the United States. And it's all about heat integration, process control and process integration, and then of course fundamentally changing the setup, but this takes longer time, and digitalization helps us a lot in further bringing down the CO2. A big challenge, and this is something BASF is working on, and also a few other companies. You know, everything starts with a so-called cracker. The cracker contains a furnace. And the furnace is basically, as you on the left-hand side, is taking the naphtha into quite of a heat a process where we use natural gas to make these tubes, extremely hot, 850 degrees. And then we create cracker products, olefins, propylene, ethylene, and everything. And of course, the natural gas turns into CO2. So this is really the traditional process of running big plants at BASF and everywhere else. And this one we want to replace to what we call an e-furnace. The e-furnace basically also needs the 850 degrees and has a setup which is comparable, but it needs completely new technology. It's very demanding because finally we turn renewable energy, wind and solar, and we use the electricity to heat the whole things up. So this is not in place. This is really basic studies, and here we need very good engineers. It's a difficult process, but it's possible. And you see the CO2 footprint is much lower, provided we use renewable energy. This is a huge challenge for BASF, but it will have a significant effect on CO2 emission if we succeed with this challenge. A second one you have seen in my slide on ammonia synthesis. Hydrogen still is important, not only for future hydrogen-driven cars and fuel cells, but also as a chemical building block for basic chemicals like ammonia, but also we in BASF do a lot of hydrogenations of olefins, for big products. And if you look at this, there's also opportunities around. The state of the art is the steam reforming, the traditional way to do it, but you create a lot of CO2. You create 4 molecules of H2 and you create 1 molecule of CO2 per molecule of methane. And then you do it with steam, with water, and look at the direct emissions. What you cause quite a lot of CO2 per kg, 8.85 kg CO2 per kg hydrogen, which you get here. And there are 2 options, and both options are viable. Both options are possible and small scale, and both options are looked at BASF. And we also particularly look at the methane pyrolysis, because you see here the electrolysis of water has advantages, but also disadvantages. I will show you in a minute. The main disadvantage is that you use huge amount of energy, and this is exactly the main advantage of a methane pyrolysis. Just to pyrolyze methane and to create carbon and hydrogen, it's very atomic efficient because there's no side product of this reaction, right? Carbon and H2, but it's also a demanding process if it comes to industrial scale. And both processes are different. Both processes bring a lot of advantages regarding CO2, but as I said, the water electrolysis has the big disadvantage of very high energy demand, but has the advantage of water as raw material, and there are already industrial scale plants, first plants available. The other one where we work on has the advantage of low energy demand. You see, it's much lower. It's a little, not a third, a little more. What is it? Not a tenth. It's 8 times lower. And but we still have to need fossil raw material, but gas, not oil. And here we are not in a higher scale. We have first pilot plants, but this is interesting for the chemical industry also to look at H2 from methane. Yeah, maybe I showed you some examples regarding now the battery technologies, cathode materials to foster electromobility. I have shown you large-scale operations for better carbon footprint, different feedstock, these things. I now want to show you what is the logic. How do we justify, how do we select projects if they make sense or do not make sense from a sustainable chemistry point of view. And some of you may have been last October here in Mumbai at the 6th Industrial Green World Convention. And you may have seen also Paul Anatas was there. And what we are using basically at BSF are the principles of Anatas and Werner, the green principles. I do not want to give you a lecture here on this, but this is really fundamental because this is a quite of an objective measurement to compare process with process. You see on the left-hand side, the 12 principles of green chemistry, what we should achieve in green chemistry. And you see also with the focus, this is what BSF, what we normally look at in very much in detail. And then you see the same on the green engineering. It's all about to have much more sustainability in our processes. So I show an example how this works. This is example. I cannot give you examples from right now from the project portfolio because this is all confidential. This is a very famous one, the so-called cyclododecanone, the CDON, or similarly with the cyclopentanone, the CDON or the CPON. And these are cyclical ketones, which are very, very important. The first one is for polyamide 12, and the other one is very important for fragrance, crop protection, electronic materials, the 5-ring. And you know, the point is, if you do this classically, it's absolutely very low sustainability in terms of the raw materials and what you are doing, and particularly if you look at the classical oxidation. So, but then what we did here, and we made out of a drawback an advantage. This is the ideal case because BSF through the Faboon, we had available N2O as a byproduct. So N2O is also a carbon, a greenhouse gas, and it's not a nice thing. But N2O is an oxidizing agent. And what we then do, we used originally an ICAI patent. This is known since many years that it's an oxidation agent, but it was not easy to develop from there into industrial scale. And we did this with mini plant technology, but now all our plants on this oxidation step here worldwide run on N2O as an oxidizing agent. You see here on the bottom of the chemical reaction, you see the old from Verbund. We come with a butadiene, and then we do the cyclization, and then the traditional way went through a boron chemistry and a lot of things, you see, and finally we create also a lot of waste to enter into polyamide 12, and this one on the top is basically an ideal case on green chemistry because it has really high score. What we do, we take the N2O from the Verbund, which otherwise would have to be discarded, you know, or treated to as a waste, and we use it. We get basically 100% yield with a catalytic process. We use the H2 from the Verbund still in the old way with steam forming, not in a modern way. This is where we work on, I showed you. And then we have basically the cycloketone. And if you then look at the whole thing from these principles of green chemistry, and you look at principle of green engineering, this process, of course, has extremely high scores in terms of prevention of waste. And atom economy is ideal. We have no waste anymore from this oxidation. And also other features, of course, are much, much better than in the old process. And this is what we do now in many projects around the world. We look what can we do, brainstorming. We invite also universities to look at this. Then we come up with the first proposal on a new potential process. We go into labs, we go into KG labs, we go into mini plants, and then we in parallel we do these calculations. And if we have high score, it must be high score, because only a few points higher does not make sense to change the process on industrial scale. But we have high score, huge improvements, then we go and we substitute the old process with a new one. Yeah, I want also to, this is not new to you, and it's also not new to the world. Circular economy means basically we make the best use of what we have. And we avoid really to create a lot of mess, which we don't use. I drive every day. When I drive to campus, I see the huge dump ground here, you know, in Mancourt here at the, what is it? Kanjurmark. And this is what we cannot continue to do. We cannot just dump the whole stuff to sites and wait and see, and next generations have to take care. And this was in the past, circular economy was done because of shortage of materials. People reused it and so on. This is how my parents did it, Second World War, before my grandparents, out of shortage. Now we do it as a basic principle to make our life much more sustainable, and we need to do it. We urgently need to do it. And the whole thing is, as I said, old, but it basically started to gain really importance 2010 with the so-called Ellen MacArthur Foundation. They made the concept widely known. They really showed what could be done if we fundamentally change our also way of thinking about this. And then the EU adopted these principles and came out with booklets, some not laws, but basically recommendations, action plans to slowly but steadily turn the economies in the European Union and also other geographies now, of course, heavily China, Asia, India, US, everywhere we work now on very strongly on circular economy. And what is it? This is a very simple thing. It's an economy where we basically have to stop to couple economic growth, so to relate always economic growth with more consumption of energy, more consumption of oil, more consumption of whatever, water, everything. We say we should maximize the decoupling. So we still have economic growth. We have more people in the world. We need more products to develop economies, more tons, more whatever. But we should not come up with always more kilowatt hours, more CO2, more oil, more whatever. And this is very important, a very, very important thing. And science can do a lot here. And you see the elements are resources to keep it in use as long as possible, durability, minimize disposed residual waste, extract the maximum value from product, and recover and regenerate. And we always have, if you look, the linear thinking goes from the origin, from the resources to the dump ground, right? This is the old thinking. We get rid of it and then goodbye. And this way of thinking means in every step, from raw material production, back from processing, back from manufacturing distribution, back, we can circle it back to the earlier stage. And ideally, at the end of life, we bring it back into the first stage on getting a substitution for finite resources. And this is something which is extremely interesting, but also extremely demanding, because it's not only a change of individual technologies, it's a whole change of our thinking. What we have been used the last 100 years, we have really to change now. Give you just an example on a product side, which is quite important here, because we have an issue. As I said, now 100 years ago, Staudinger in Freiburg, he discovered macromolecules. You know, this was unknown before, and then all the polymers started. You know, polyurethanes, polyesters, polyamides, whatever, polyolefins, polyacrylates, and very much of these foils, these are PP or PE or polyacrylate based things, but they are not biodegradable. And this is a very important field of product innovation at BSF, where we can to substitute non-biodegradable with biodegradable, because this is very nice to close these loops. And of course, we have in many countries, we need mulch film, which we put down on the fields, and these films, then the farmer cannot remove all the films at the end. They should be biodegradable, and this is here a film with a material which is biodegradable, avoids the pollution, what is called white pollution of residuals of the foil. And we can have a lot of benefits here also for the farmer, efficiency, water savings, and so on. When you calculate what it means for the farmer, for the end use, then he has a lot of advantages. Another one, here in Maharashtra, where we are sitting here, we have a ban of plastic bags, right? Because everything ends up in not compost, but on the dump ground or so. And you also can use a biopolymer and hybrid biopolymer-based approaches to make very nice bags, which are certified for compost. If you have a home compost, then you can buy these bags and you put it in your compost, and it is absolutely biodegradable, and so it's basically ideal even for the bacteria which degrade your compost. They also have benefits from it. This is very nice on product sustainability, and that's much more in BSF, in detergents, in cosmetics, in lubricants, in additives, and so on. We have to replace some really old products which work fine, but which have a bad record and a very bad non-biodegradable, non-degradable at all. We have to try hard to substitute these materials. Yeah. I come closer to my end with the chemical recycling, and it's funny, chemical recycling now is in a stage where we can say it's working. Yes, we have pilot plants. We even have some plants there's one in Spain, in the UK. We have here in India also a few smaller plants. I'm in close contact with a company here in Belapur, and they have a plant not far away from here, 60 kilometers towards Pune. And this is a very interesting feature, a very interesting concept, because it addresses a big issue. And it's very close to the topic we are talking about, green, and to make the world more sustainable. What is chemical recycling? You see on the bottom of this slide, you see what I call the linear thinking, which was happening in the past. And even when I was young, we bought the stuff and we disposed it, and that was it, finito. You go from buying, and you go finally linear economy, you go to landfill, the traditional way, or littering, the traditional way, throwing it away. Now, if you go up then from there, you see already, and this is existing technology, that we have some processes, waste to fuel, and particularly incineration. This is where I'm from Europe, Germany, Switzerland. In winter times, of course, we need heat. And the city of Basel, where I'm from, we have basically big furnaces where we burn all our stuff, the plastics. And then we have warm water, and we have a nice temperature in our houses in winter. This is not bad, because you make use of the waste, but it's not ideal, because we create, of course, a lot of CO2. We burn the stuff, right? We burn the stuff. Also, waste to fuel means you create CO2, but you don't create landfills. This is it's in a way in between. What we have to do, and what some countries are really starting to do now strongly, Switzerland, Norway, Sweden, Finland, you can do it by law. You can say, stop the lower one. Linear economy is basically more or less gone in these developed countries. You are fined when you litter, and you are not allowed to do landfill. So this is gone. But also the second one has to go. Now for India, the first one also has to go first. Landfill maybe, but you don't have cold winters, you have to do it differently. And then we come to closing the loop. Closing the loop means we really have processes, sophisticated process to separate everything from our garbage and to put everything which is in pure form. From car, you have the boards in the car, you have the tires, you have certain things which are uniform. There you can also look for processes for mechanical recycling or PET bottles. This is the biggest success in India. PET, really, there, I think we are in many countries close to perfect, including India. But there's a lot of plastic materials which are so mixed and which are also composites with metal foils and paper and carton and whatsoever, where you cannot do a mechanical, physical recycling. And there is now, this is the field of ChemCycling, because there what you can do is you don't burn it. With oxygen, you heat it up in a pyrolysis, and then you basically reverse the polymerization. So you just come back from the polymers to the monomers and to certain gases, to an oil, to kind of small chain molecules. This is chemical recycling. So I show you a small movie.
Plastics are omnipresent, but so far, only some of them have been recycled sensibly after use. Classic recycling processes are coming up against technical limits. There are plastic fractions, such as mixed plastics or contaminated plastic fractions, which cannot be recycled efficiently in this form. Exactly these mixed plastics are important for us as a raw material for the thermochemical processes that we use in ChemCycling. With ChemCycling, we're describing a process along the entire value chain. It starts with plastic waste, which is otherwise very difficult to recycle. We make chemicals out of this, and at the end of the value chain, products can be manufactured from these, which are 100% made out of recycled materials. For ChemCycling, BASF is working with companies along the value chain. Plastic waste for testing is provided by Remondis. Plastic Energy, which operates plants in Spain, as well as Resenso GmbH from Remscheid, Germany, work with processes such as direct oiling or pyrolysis. They've specialized in turning plastic waste back into oil. We take plastic waste and turn it back into an oil. Plastic waste from recycling, yellow sack, or also from processed household waste. And the product that we manufacture is an oil that can be used again in exactly the same way as oil in the processing industry. The steam cracker in Ludwigshafen. Chemical-based products are being produced here, so far made of naphtha. These chemical-based products serve as raw materials for the entire Faboon site. With ChemCycling, however, a new source of raw material will be added to this. With pyrolysis, the long-chain plastic molecules, which are interwoven very tightly with one another, are divided into smaller pieces. This turns a solid plastic into a liquid oil. This oil can be converted into base chemicals in a steam cracker. In turn, these base chemicals can be processed further into pure plastic granulate. The customer can determine how large the share of recycled plastic is within the context of the mass balance process. The first applications range from food packaging right up to refrigerator doors. We are still in the pilot phase of the ChemCycling process. There are obstacles that we need to overcome, technical obstacles, such as the purity of the pyrolysis oil or regulatory frameworks, which need to be created so that BASF has the opportunity to develop a sustainable business model. We are convinced that with these processes, we can make a significant contribution in order to get to grips with the global waste problem.
Yeah, Yeah, good. I end now my talk with another initiative, which is also important here in India. You know, this is a picture from Mumbai, not far away, Methi River, the very nice river originally. We have a lot of plastics also around, as I said, not only in landfills, but also as a litter. And this is something now also which is addressed in India, and I'm very happy about this. And the whole thing is also supported India, but all over the world with the alliance to end plastic waste. This is a big, big issue. I cannot go into details, but it goes a microplastic spoiling the oceans, fish, we get it back through our, food. It's a health risk, it's an environmental risk, it's a sustainability issue, huge. And basically a lot of companies worldwide, upstream like Procter & Gamble, downstream like P&G, upstream like DSM, Shell, BSF, and so on are working together here. And what we are doing here in India is we support as a consortium projects also in India, and we have here the Ganges River, the holy river of India, which is the second largest polluter after Yangtze in China, a huge river. And there we support initiatives, and it's not only about technology, of course. To transform plastics to naphtha and make chemicals out of it is one thing, but you have to collect it, and you have also to make it possible that things can be separated and so on and so forth. It has a lot of also societal issues, but I'm proud that BSF also is supporting this initiative, which is really a burning topic. Yeah, and I stop my talk back to my city, Basel, just to show you what is possible when I was a boy. I'm now 61 years old, but when I was 6 and 7, with my father, we walked over the old bridge. This is the main bridge, the historic bridge of Basel. And at that time, I asked my father, because sometimes the river was blue, red, green, dirty, nobody was in the river, I tell you, nobody. And my father told me that the chemical industry, I did not know what this is, but that they produce dyestuffs and then they clean their vessels, They clean their reactors and they had no sewage treatment, nothing. This was in the 60s. And the river was so dirty and stinky. Now, due to investment and technology, this water is so pure that basically nothing would happen if you drink. And in summer times, we enjoy to swim in the middle of this city. You can swim 3 kilometers. You just can float in the river. And this is also due to not only awareness, but also, of course, spending money. But this is enhancing quality of life a lot. And this stops my talk. Sustainability is so key for society and so key for our industry that this will not go away. And you as students, you need to be very creative and look at, and it's many elements as I tried to explain, a lot of elements, a lot of disciplines, all we have to work together to make life better in future. Thanks a lot for your attention. And now I'm waiting for your questions.
Thank you, sir. It was indeed a very illuminating talk. I'm sure all the students, industrialists, and participants would have tremendously benefited from your deliberation here at IPGT. Thank you, sir. Over to Vaidya, sir.
I thank you very much, Dr. Dietmar, for the wonderful lecture that you have given. Please accept our compliments. I have a couple of questions for you. First is, if you could tell our students what a biorefinery is and what could possibly be done with it in future. And the second question is, if you could tell our students which way green technology will go ahead in the next 2 or 3 decades.
Yeah, maybe first, biorefinery, to my understanding, this is that we use biomass. We use biomass to make chemicals, and the one is basically ethanol, of course, but we also can use different things. I know at the NCL Pune, for instance, lignin is another question. So this is already important, will become more important. The very important point on biomass and this type of activities is that we should not compete the raw materials from food, and therefore we have to look particularly for crops or for regions in the world which cannot be used to provide food crops, but other type of crops which then can be turned in sugars or then later in alcohols. This is one of the big streams to replace fossil fuel with other type of renewable resources. It's very important, I would say, and it will be more important in future.
And the second question was about where green technology is headed to, which way we will go in the next 2 or 3 decades.
In my, maybe what I have shown you, the green technology, the direct is green are plants. We do something with plants. What you ask, we make use of plants. Green, because this is chlorophyll, this is plants, but this is only an element. Basically, green technology relates to so many different things. To make the world more green, as I showed, relates also to make existing processes better. Maybe changing the setup, having better feedstocks, looking for alternate energy input, making products out of waste, and then making it in a circular fashion. All this is related to the green principles and to green chemistry. And we also have to understand there is not a contradiction between feedstocks which are plant-derived and feedstocks which are not plant-derived, because there are a lot of hybrids that we use both streams, and it's an illusion. In my opinion, it's an illusion to believe that every product we have now, you know, polyesters and polyamides and everything what we have to use also for automotive future can be produced by only using so-called green feedstocks. This is not possible because we cannot, you know, the material properties still must be possible. We cannot see a world where everything goes back to natural. If green chemistry is seen as only natural chemistry, I'm absolutely not believing that this is possible. But if you see green in a wider scope to make everything what we are doing more sustainable, then there's a lot of potential. But we should not exclude the chemists to do this thing from the chemists to do the other thing, because everything is required. Everything is required.
Correct. It was so nice to listen to your lecture. When this pandemic goes away, we hope to see you sometime in ICT. And when you are here, we would like to show you our labs, what kind of work we are doing.
Very nice, yeah. Very nice.
And I will also introduce you to my colleagues at that time. And our students will also be very happy to meet with you in person.
Okay,
so thank you.
Thank you.
Thanks once again.
Thanks a lot, yeah, and wish you a nice day. Bye-bye. Bye-bye.
Bye. Thank you.
Bye-bye.
Bye. Bye.
Thank you, sir. Thank you, sir. Thank you, sir. I would now like to introduce our next speaker, Mr. Ramakrishnan Mukundan. Mr. Ramakrishnan Mukundan is the Managing Director and CEO of Tata Chemicals Limited. He joined Tata Administrative Service in 1990 after completion of MBA from FMS, Delhi University. He is an engineer from IIT Roorkee and an alumnus of Harvard Business School. During his career of 30 years with Tata Group, he has held various responsibilities across the chemical, automotive, and hospitality sectors of the Tata Group. He serves on executive committees of various industry forums, Confederation of Indian Industry, Bombay Chamber of Commerce and Industry, Employers Federation of India, All India Management Association, etc. We are extremely elated to welcome you for today's session, sir. We hope your contributions on sustainability would illuminate us. I request the participants to kindly ask relevant questions in the comment section of YouTube, which will be passed on to the speaker by our team. Mr. Mukundan, you may please begin with your talk.
Thank you, and good afternoon to all of you, and I'm extremely delighted to be amongst all of you. ICT has always had a very special place for Tata Chemicals. We've had a special relationship with ICT in terms of the work which has happened for many years, especially in Metapur. And absolutely delighted to engage with you. And I thought the next 1 hour, maybe we spend about the 20, 30 minutes through going through a quick presentation on what we do. And then we could probably have a series of question and answer and take it in the direction we need to take it to. I've got my colleague, Dr. Richard Lobo, who is the head of all our R&D labs, helping me, and the presentation largely has been made by him. Uh, for all its clarity, I just want to say that I'm an electrical engineer. I'm not a chemical engineer. So if I make some mistakes, I have to go back to my basic chemistry, which I learned in school. Having said that, I think engineering is such an interconnected field. One can apply the knowledge you glean in one area into another area. So I was listening with intent. What was the discussion about green technology versus green chemistry versus natural chemistry? And I think I tend to agree with the comment which has been made by my esteemed previous speaker, that I think we have to look at green in a slightly broader sense. If we narrowly project it to what comes from nature in natural way, I think we will not get there. I can also tell you the kind of work we did at one point of time to mimic photosynthesis. This work we carried out in our overseas lab where we were trying to say, can we mimic photosynthesis? But all the elements we were using were inorganic chemicals, inorganic chemistry. It was not organic at all. It was not natural chemistry. And we did mimic photosynthesis using those chemistries. But I just wanted to say that I fully agree with what has been said. Since Tata Chemicals is what I represent, I must do a bit of advertisement for our company. It's part of the job description. So, Richard, if you go to the next slide. So this is where our journey started. This is a city of salt, Mithapur as we call, and we are even today Asia's largest inorganic chemical complex. We produce a variety of chemicals there and variety of chemistries, and it's fairly integrated, which is what gives it a very, very competitive cost position, and it continues to grow. And I think the site is expected to grow 50% more in the next 3 years from where it is today. And a big amount of capital investment is happening in this site. And it still, even today, remains Asia's most competitive site in terms of the chemistries it deals with. And it is in this site that a lot of ICT professors have helped us with respect to process efficiencies and process improvement. Can I go to the next slide? While we have started our journey in Mithapur, we are today spread across 5 continents. Our largest operation is in Wyoming in USA. We also have operations in UK, where we are near Manchester, where we've got both a salt and a inorganic chemical plant. We've got an operation in Kenya. And within India, we've got various factories. In Gujarat, we've got factories at Ankleshwar, at Dahej. We also have factories in Maharashtra, in Lote and in Akola. More recent factories of ours have been in south of India, especially in Nellore in Andhra Pradesh, and one in Kadalur. The one in Nellore actually is set up with smart manufacturing industry 4.0 standards, and it's state-of-the-art plant which actually has a vertical technology of fermentation, and in fact uses that horizontal technology of fermentation, and produces various products out of fermentation technology, especially in the nutrition space. Next slide. We have 4 verticals broadly in the company. First one is performance material. This is really what started the company. It started with soda ash, bicarbonate. Recently, we got into entire platform of silica, and highly dispersible silica was the first product which we are selling to tire manufacturers for green tires. As the new norms come for tires, they need to substitute a bit of carbon black with the HDS, and that gives it a better lower rolling friction, and at the same time gives better properties in terms of heat dissipation. We also have a nanotechnology, a series of nanotechnology products. One biggest of them is nano zinc, and these are built on a very horizontal technology, a horizontal platform R&D lab, which is based in Pune, which specializes in nanotechnology. Agri-sciences is mainly done through a subsidiary of ours called Rallis, and they reach to over 80% of India's farmers. And they have several molecules where they have global leadership, and they are fundamentally now getting into synthesis of various generics, and they don't do what I call as uh, the new discovery molecules, and they are focused on those which are coming off patent and synthesizing them. In terms of, we also have within agri sciences a seed division, which is currently within India. We sell only hybrid seeds, but globally we have we are testing, we are bringing to sort of market the various traits through genetic modification. The approval process in India has been cleared now to do genetic research, but for few years it was suspended, and that led to a bit of a delay in terms of getting high class products to the farm. In terms of nutrition science, this again is a large vertical for us. We are one of the largest edible salt manufacturers in the world. We also are sixth largest producer of bicarb for food and pharma industry, and we started the first oligosaccharide plants, both for fructooligosaccharides and galactooligosaccharides on the fermentation technology out of our Nellore plant. And we will be, while we are present in short chain FOS, we will also be getting into long chain FOS shortly. And that entire factory is set up to become a horizontal fermentation technology factory, and that's where our biochemistry sciences comes into play. The last one is energy science. This is clearly a green business for us. This is fundamentally start with the recycling of batteries, lithium batteries, and then we also do active ingredients. Those extracts which we get, we sell to other people. But eventually, we are also in the process of getting into the battery energy storage business itself. We have several partnerships with CSIR Lab where a lot of this work is happening. Next slide. So this is sort of tells you about the scale of the company, and we are either first or second in most of the areas. And we try to move towards leadership. Where we are not leaders, we would end up being leader over a period of time. And we are looking at very green products as we go along, as I explained, in terms of HDS or the natural extracts, which is part of the business which we have in nutrition science, where we're building a new series of business based on aeroponics and hydroponics in Monday. Next slide. This is broadly our strategy. This is what we do, and our mission is to serve society through science. And if you really look at it, it sort of tells you what are the products we are in by vertical. And within nutrition science, I explained to you about this natural extract business, which is really one which I would say plays upon natural chemistry, or a slightly narrower form of green chemistry. Next. So this is our strategy going forward, broadly our size and what we are doing. We want to maintain leadership in performance material. We want to drive growth aggressively in nutrition and agri-sciences. And in energy, we are building new technologies, and we work with CSIR Lab. Next. Our values are very important to us. Safety, being a chemical company, integrity and care and excellence are all values which Startup Group has, and we continue to oppose those values. Next. Next. And we also believe fundamentally in being a company, we have to give back to the society. So we have set up several institutions, including Tata Chemical Society for Rural Development. We also have an entity called Okai, which is which sells fashion brand, but these fashion brands are manufactured by tribal women and local villagers who live near our factory. And this is a picture of them making those products for sale in the market. So fundamentally, I'll dive into this whole approach to science and business which we have. Our approach to science and business stems from that science has to solve everyday problems of our society. And that's how we approach this. If you look at the next slide, Richard, when we got into branded salt and we launched Tata Salt, really our issue was not to sell salt. We wanted to ensure that we played a role in iodization. And we put our hand up when government wanted to sort of eradicate goiter. And it is with that approach we started this brand, and this now has become the biggest salt brand, biggest food brand in India. And that was to solve the society's problem of goiter. More recently, we've also launched what I would call double fortified salt, which is iron, because most Indians also have this problem of anemia. And we have Tata Salt Light, which is also solving another problem that salt does cause increase in BP. So this one is meant for blood pressure management. So fundamentally, our approach to business is find out society's problem and address them through products and offerings which you can give. Next. Now, our approach to green chemistry is while we can start from natural resource, but many of these have to again solve the issues of what we call as sustainability and also real problems which we have. For example, this chart explains this whole silica and what we've done with silica. When we started this business, we actually did not start with rice husk ash as far as our the highly dispersible silica is concerned. We started this business with the traditional silica and then moved forward to deliver the product to customer. But now our scientists are working back to say, can we start with rice husk? Can we start with tobacco waste? Each one of these are very much rich in silica, and then use that as a basic material. And as we do the process, we also patent the product and patent the process so that we have some differentiation. If you look at our water purifier, again, it uses this whole issue of rice husk ash, which is a very mesoporous material. And in that material, we have actually impregnated with the nano silver, which acts as a agent which sort of kills the virus and bacteria, and also filters and purifies the water as it moves along. And this was launched as Tata Swachh, which is selling in rural markets and is solving the problem of pure drinking water. So this tells you an example of pick a chemistry and use a chemistry to solve a problem, and use that methodology in a way that it is sustainable and it's green. Next. The other example which I wanted to give to you is about building a carbon capture plant, which is to build the food grade and pharma grade bicarbonate plant. We've actually invested in carbon capture technology, and we are using that to sort of create this CO2 sink, use it as a CO2 sink in making bicarbonate. And this again got green funding. This was partly supported by government in terms of its green credentials, but this first of its kind in terms of using CO2 from power plant to build a very high quality product for food and pharma. And you'll see more and more such examples coming worldwide as people begin to look at chemistries which will drive environment sustainability and at the same time ensure that that the cost structure and the business value which is created is either same or is more than the traditional route. Next. If you look at our approach to the electric business, this has been done primarily through a circular economy approach, wherein we started first with battery recycling and then moved into actives, where we are giving these active materials to battery manufacturers. Parallelly, we are also working on batteries, but the entire approach was, if India goes through electric vehicle revolution, where energy storage becomes the norm, and there's electric energy storage through batteries at the end of their life, we also need to solve the problem for that. And we applied what is known as the circular economy principles, and then we set up actually the lithium recycling unit first, and extracted the materials from the lithium batteries. Right now, we are doing this with the laptop and mobile batteries, but the intent is the same technology can be used to also get this out of the EV and stationary storage batteries. So fundamentally, the approach here on the green chemistry is to reduce damage to landfill, to minimize environment impact. And also it allows you to bring back to life strategic chemicals like cobalt is actually a bit of a short supply. There are issues with respect to the mining and the way the mining is done for cobalt. And by making sure we don't have to endlessly produce cobalt by recycling it, we are able to sort of achieve the green credentials for the same. So fundamentally, the whole approach of ours is any unit, zero liquid discharge, zero solid waste. Make sure that we do CO2 abatement, and this year we have actually we are going to announce shortly our commitment to CO2 in terms of climate change commitment to sign. We've signed up for SBTI. We're going to announce our targets to keep our operations well below 2 degrees, and that commitment is the first step. Finally, we would move towards net zero, and all this effort is to make even our current businesses more in line with what green chemistry is all about. Next. Uh, this is more the narrower definition of green chemistry, right? So this entire vertical is born out of the fact that the plants themselves have a lot of chemicals and chemistries which are very useful, both from nutrition perspective and from pharmaceutical application perspective. So we've actually set up this entire unit in Nanded where we are using what we are doing is we are industrializing farming by going ahead with aeroponics and hydroponics, where you can grow in each one of these lanes a plant which sort of matures in 1 week, next one matures another week, so you have continuous production. And then these critical ingredients of these plants are then extracted. For example, curcumin from turmeric, pepperine from pepper. I mean, these are all the kind of stuff which our team is looking at. And there's a whole series of plants with which they are sort of making, having the experiments done. Idea being at some point it will be an industrial scale natural extract unit. And this is a clear example of how companies are now going towards nature to sort of get active ingredients which may have come sometime from chemistries in the past. Next. So a bit about what we have done in the last few months in terms of making sure that we have products which can support the current pandemic COVID. We have been supplying this nano zinc, which acts as an antiviral agent, and some of the mass suppliers are actually coating this to make sure that it acts as a good uh, way to sort of reduce the viral load. Next. This again is an example of what we've done in our largest site, which we started with, which is all about the whole issue related to can we do circular economy. And the way it approaches there is when you make soda ash, you have a lot of residue and a lot of solid waste. And all the solid waste is extracted and filtered and is put back to make cement, which uh, which is a useful material, which we then sell locally in Gujarat as a cement. So in fact, we've invested in a cement plant just to make sure that we adhere to circular economy principles. And there's a whole host of stuff which we do in that area in terms of our responsibility, making sure wetland development happens. We maximize the use of solar and wind energy. Uh, we will be switching over to bioresources for in our boilers so that we are more green, and also using concentrated solar at some point of time to generate steam, so that even the steam is done without use of carbon. In the last 1 year, we've set up two entities. One is Center for Sustainable Agriculture and Farm Excellence. This is being done by Rallis, our subsidiary, which works with farmers for making sure that whatever we do at the farm level, it is more sustainable. This goes beyond carbon. This goes into water and stuff like that, and propagating, for example, the whole issue of SRA in rice cultivation, making sure conservation of water is adhered to in agriculture practices. Those are all the stuff which this team does in terms of extending help to villages and farmlands. And we also set up an center of excellence for coastal and marine conservation. This is because a lot of the products we do comes from seawater, and we do believe that we owe it to at least because that gives us the basic reason to exist, that we owe it to the marine ecosystem to protect the marine ecosystem. We've done several stuff in this area, including transplantation of coral reef from Lakshadweep to Gujarat coast. We have a very active program of protecting whale shark. Uh, just like the Project Tiger, which is for terrestrial animals, for us, protecting whale shark is a project in terms of making sure that the marine ecosystem is well protected. So all that work happens through this center. So the key issues the industry faces in terms of greening itself is fundamentally around industrial emissions, and these are both gaseous and other forms of emissions which we have, and how do we sort of make it zero, or at least in some cases create a process of at least abating those emissions through some mechanism and methodology. Then there is the whole issue of energy transition. Everybody has to play a role, and uh, this is a business need, business imperative. It also could be seen as a business opportunity. So there's a whole host of new businesses which are coming in terms of the renewable business, sustainable energy businesses. So I think that throws up a whole gamut of opportunity for everybody. Then this whole element of chemical and biological processing, how do you sort of use biochemistry to get your products which you need, and how do you sort of make that process itself more green by making sure the wastage is minimized and output is maximized. Then there's a complete revolution happening in terms of advanced materials, and people are working very hard in this space to make sure that they can deliver the features which you need in a specific product and properties which you need in a specific product while engineering for the lowest impact on the planet. Uh, Certainly, this whole circular economy, we need to look at it. Every business has to address that issue. And lastly, where you cannot address this circular economy, you have to look at how do you manage the waste and how do you make the waste to at least become some form of energy, or so that it's not creating solid and it's not creating landfill and it is not polluting the air. All these things come together. So these are the issues which I think, in broadly, the green chemistry needs to address. And not all of this has been solved. There are several elements which industry is grappling with. But if you ask me, what are the 3-4 trends the industry is facing? The industry obviously is riding on 3 trends broadly, in my view. The one trend is digital. Everything will get digitized at some point. Second trend is sustainability. So this green chemistry falls right at the center of that sustainability piece. And the third issue is around technology. When I say technology, it is around new materials, new ways of doing things. So it is at this intersection the business opportunities are arising. So this whole topic which you asked me to speak about is very apt and is going to unfold at a rapid pace going forward as companies and countries have to keep up with their commitments, what they made to each other. I can only see huge opportunities in this space. Uh, Thank you for this opportunity to present this briefly, what we are thinking about in terms of green chemistry and how we are approaching it. I'm happy to take any questions. My colleague also is here. He could also address any questions which I may find difficult in answering. Thank you.
Thank you, sir.
Richard, I can take out the presentation. Sorry.
Yes.
Go ahead, please.
It was indeed a very scintillating talk, Mr. Mukundan. Thank you, sir. We hope the future is more sustainable and greener with our collective efforts. Vaidya, sir? Vaidya, sir, you're not audible.
Good afternoon, sir. Can you hear me?
Yes, sir. I can hear you.
Thank you very much for this nice lecture. I had a couple of questions on behalf of our students. My first question is, how does one measure the extent of sustainability of a process? Or in other words, what are the indicators of the sustainability of a process?
So I think we have what we call as a green manufacturing index. We have developed it ourselves. So if you ask me what is the GMI number, we have a number internally. It is done on a rating of 5, and we know what happens. But it has several elements in it, which includes, for example, what is the carbon intensity, what is the water intensity, and what are the wastages. So I think it measures everything and comes to a rough indicator of what it is. So it is around that we sort of measure. And if you ask me what are the three broad metrics, the three metrics would be what is the level of waste to the actual input ratio, what is the carbon intensity to the output ratio, and what is the water intensity to the output ratio. And the effort over a period of time has to be to figure out a way to sort of bring all this to zero. So you get to zero carbon, you get to zero water, you get to zero. So you cannot reach zero. In many processes you will need, but you then keep on trying to reduce it to make sure it's only a makeup amount rather than the full amount. And that's our effort. Where we have not been able to succeed has been things like, for example, seawater. We've generally said that let's first get rid of the freshwater input into the plant. Let's not go there. If we are using seawater, let's not put a constraint there, because to us the seawater is very large in quantity, and we are only altering the temperature. We are not altering the composition of seawater. But at some point we have to address that also. So I think uh, our measure uses these three metrics, but it excludes the seawater. So I just wanted to be very open about what we do. But we haven't come across a single metric which is uniform across. So I just want to say that we use a metric internally, which is what we measure our operations by. Uh, but if there is something which you can suggest to us, we are happy to adopt it. Very happy to adopt it.
Yes. Sir, in the classroom, we tell our students that there are 4 ways to measure the sustainability. One is the efficiency, the other one is the energy, the economy, and the environment. So we try to tell in terms of these indicators. Sir, my second question was if you could tell us maybe a couple of examples where, for example, Tata Chemicals had a process that was less greener, and then through your efforts, you made it more green. You could tell us 1 or 2 examples of that type.
So I think as far as we are concerned, as I mentioned to you, the factory in the new plant which is being built in UK, which is going to capture the carbon out of our power plant and make it into useful bicarbonate, I think is a clear example of what we call as it reduces the carbon emitted to the air. It produces a product which is needed by the market, and it is also producing to the quality of pharmaceutical grade. So it is something which we are going through as we speak. The second one, which I already highlighted, the entire solid waste. If you look at the chemical engineer's solution to pollution is dilution. Very fundamental. They've arrived at this whole point that I have solved the problem by adding more water and making sure that it is diluted, and they will give you this measure as a metric. But then if you tell them, listen, that is not an acceptable solution. You need to eliminate. And if you start with the objective to take it to zero, again, which is why I'm saying zero should be some of our fundamental route to get to a point where we don't end up with that. That also is a solution. I'm not going to say it's not the right solution. But if you really want to be green, I think the idea is to move to zero. So we usually, if you look at soda ash plants, they all discharge their effluents, solid effluents, after diluting it, so that it is looking like a clear water into the water bodies. In Europe, they put it into River Rhine, for example. Everybody is taking it to River Rhine, and in India, most of the factories would be taking it to the sea. What we have done is we actually separate the solids out, capture all the solids and siliceous material, and we built a cement plant to use that solid waste for producing a product. If you ask me, do you make profits in selling the cement? I think it's just about break even. It doesn't make profit for money for us, but it at least stops us from putting those solids in the sea by diluting it. Our TDS numbers are way below what the norms have been established. But really, I think the idea is that if you can convert your waste products to useful product before it moves out of your boundary, you are moving towards more greener process. So we as chemical engineers, we have to think all the time. And the good thing about chemistry is that, it will be another series of 2, 3 reactions or some 2, 3 steps further, right? It will be either separation, filtration, or combination, something it will be. But you'll get to a useful product. If we can do that in a very purposeful way, then we create value which companies can capture, and it is also becoming more green. Also, I wanted to add that our entire HDS, highly disposable silica business, our entry into silica itself as a platform was driven off green consideration, because we do believe in the long run, wherever carbon can be replaced by silica, it will be replaced over a period of time. Because carbon is a problem which we have to all address. It's a very useful molecule, but it is an issue which we need to address.
Sir, if you permit, I have another question. You mentioned about seawater, and you're doing quite a lot of things using seawater. Are you also into uh, energy production using seawater? For example, seawater batteries or microbial desalination cells or something of that type. Is Tata Chemicals doing something into that?
In terms of producing energy from seawater, we are doing none of that. And I think the only thing which I can tell you closest we are working is on sodium batteries. This is fundamentally using sodium chemistries, and sodium is very plentiful in the seawater. I think that is something which we've been working with the various institutes, CSIR labs in India. And the reason for that is India doesn't have lithium deposits. So if India has to build an energy storage which is sustainable in the long run, which is not import dependent, and we build it from our own resources, we will have to look at sodium chemistry. It has its own challenges, but I think at least 2 or 3 approaches we have taken are yielding results. There is still a long way to go in terms of energy density and all, but I think it's a matter of fixing the technology rather than technology not being there.
Fine. So, thank you so much for patiently replying to all my questions. Thank you so much for giving us such a nice lecture. Uh, I will quickly summarize in a couple of minutes about our program. You know very well about UDCT or today's ICT. So we have this program on Master of Green Technology at ICT. It started in 2009. Our first Vice Chancellor, Professor G.D. Yadav, was instrumental in starting this course. So this Center for Green Technology was established at ICT in 2009, and in 2010 this program for Masters in Green Technology was introduced. Also, we have a PhD course in green technology. So since the past 10 or 11 years, we have these students, these group of enthusiastic students who want to know more about the industry and how green technology is being practiced in the industry. So it was very nice of you to share your thoughts with us today. We hope that someday you will be able to visit us so that I can show you what kind of work we are doing here at ICT. I can also tell you what my colleagues do. We can show you our labs, and we can tell you what kind of work we are doing. Some of the topics that you introduced in your talk, we are also doing on that. For example, you must be knowing 2G ethanol technology from ICT. Our DBT ICT center was the one that was instrumental in that. And then we are also working on many other things like carbon dioxide capture and its chemical recycling, for example. And we also work on biomass to chemicals and biomass to energy. Anyway, thank you. Thanks again.
Thank you, Professor. I just want to highlight that as far as we are concerned, we've had a long association with UDCT from Professor M.M. Sharma. I think he's been our long time uh, thought leader in terms of supporting the operations. Then, of course, Professor G.D. Yadav has been a close friend of ours. In fact, I think he's the sitting chair of Darbari Seth, the chair for innovation, which was instituted by Tata Chemicals. So our relationship with ICT is very strong. I have come to ICT many times, so I'll be more than happy to visit the campus. It's only next door to my house, so it is hardly walking distance. So it is always a pleasure to interact with all your students. Thank you.
Thank
Hello,
you.
sir. Actually, there are a couple of questions from our students as well, and people who are asking, watching us live from YouTube. So the very first question is from Meghma Sarkar, who is a third year student from St. Xavier's College, Burdwan, that will, in the process of changing waste into product, will reduce the efficiency or quality of product? This is a basic question. Maybe if you'd like to answer.
So I think it's a good question. There are challenges. For example, when we do use the waste from the chemical plant to make cement, the sulfur content sometimes goes high, which actually sort of is not a good reactant in the entire kiln. It also leads to corrosion in the kiln, refractory lining and all. So there is a price you have to pay. So I'm not saying that it is not solvable. So we actually have a special refractory lining which we import from Germany for our kiln, slightly more expensive. So there is a cost. It is not going to come without a cost. But I think if your end point is, can I convert this waste to useful product, and you take an overall view, you will be slightly better off than without not converting it. So I think it is always a management call. And in most cases, there will be some penalty you will incur either in terms of process equipment issues or in terms of efficiency issues. But these can be solved, and I think you have to keep at it. And I think initially it will be, the penalties may be high, but over a period of time, as you get used to the process and you fine tune the process, these penalties do come down. So I am not going to say that there is no financial or operational penalty. There are. That's been our experience.
Thank you, sir. Pratika, would you like to take over? Okay, I have another question here uh, from another student. That what is your view on PCPIR policy? What is the maintenance of policy, and how far can we benefit the chemicals and allied company? And if you are wondering that what is PCPIR stands
No,
for,
we know what PCPIR is.
perfect.
Petrochemical parks, right, which government was proposing. You're speaking about that. Am I right?
Yes.
See, I think if you look at it, the PCPI policy is a well-intentioned policy, and it's a right one. Otherwise, chemical industry in India cannot grow because we will not have place to grow. We will. So Dahej has been the most successful one, but if you look at Dahej, and we are fast running out of land there. So, which is why the other PCPRs have to come. The whole issue in PCPR has been the anchor tenant. While government has identified anchor tenant, many times these anchor tenants want to convert their base material into commodities. So this is a running issue between the buyers and suppliers, the users of products and the makers of the product. Uh, if you look at it, what use will a cracker have in terms of ethylene oxide? They can pretty much make everything into polymer, and that's perfect way. But it then doesn't give you value-added specialty product. But some headway is happening. To me, the best example of a PCPR, even though it is not designed like one, which has actually done well, is Dahej. But there are opportunities in other areas, Vishakhapatnam, or you talk about Paradeep, or you talk about Mangalore. All these were touted in the beginning, but have not taken off due to variety of reasons. I don't want to get into specifics of it. It is a combination of private sector and public sector and government coming together. Hopefully, it happens in the due course, because if you ask me which is the growth industry India has in the next 10 to 15 years, it's to capture higher value out of chemical sector. Our IT revolution, we've already proven. Pharmaceutical revolution, we have proven. I think the next revolution is going to happen out of India is the specialty chemistry, intermediates, and these areas will take off, and already have taken off. And I think a lot will depend upon the whole support ecosystem which is provided in terms of PCPA.
Thank you so much, sir. We have one last question. Is it okay, sir? Can we continue?
Yeah, please.
Yes, sir. Yes, so which type of opportunities are available for early career researchers in green technology at Tata Chemicals?
So I think Richard is here rather than me answering. Maybe Richard should answer. But certainly we have four labs in India, two in Pune and two in Bangalore. Uh, the one in Pune works mostly on both biochemistry and nanotechnology as platform technologies. The lab in Bangalore is more around process chemistry and process synthesis, and also what I would call I would call it more genetic research and hybrid research in terms of the seed research. That's what they do there in Bangalore. And there are opportunities across the board, both in organic and inorganic chemistry field, but more pertaining to the four verticals. Basically, either it's nutrition or agriculture, or it is materials. I think those are the broad areas where we work in. Our lab, but our capability in energy storage and energy science is not high. We actually work using the facilities of CSIR lab today, but all other areas we've got people. I think we've got over about 200 odd scientists working today as we speak between the two labs. Richard, you want to add anything to this?
Thank you, sir. No, I think the only addition I would give is in each of our research and choices and technologies as well, we have a lens of the green technology. So, for instance, almost all the projects running at our R&D centers focus on either being greener, having lower carbon, lower energy process routes, or material substitution. For example, silver and lead substitution, the use of indigenous materials, and so on. In terms of technology, Mr. Mukundan spoke about how we chose hydrometallurgy route in the lithium recycling, and that allows us to have zero liquid discharge, zero solid waste, zero emission of noxious gases, and so on. So there is a conscious choice on both the technologies we adopt as well as how we approach R&D in the centers. And like Mr. Mukundan said, we do have a very long-standing, rich tradition of engagement with ICT. And to answer the question of opportunities at Tata Chemicals, as and when they appear, we do broadcast that, and we would welcome interns as well as colleagues who would like to collaborate.
Thank you, sir. Sir, there is one final question. It's how life cycle assessment studies are done for TCL products, and if yes, how they are helping the overall process.
We do life cycle assessment study. Richard, you want to take that question again?
Yes, so thank you, sir, and thank you for the question. The life cycle study is a very intense approach across the company, and let me point it back again to the way we heard ICT approaches green technology and sustainability. It touches people, planet, and technology, and we look at cradle to grave concept across entire value chain of our products, including the safety and the performance of our products in the market, in the application, as well as the life cycle.
Thank you, sir. Thank you, sir. It was a very great opportunity, and we hope we can connect with you in future. We also would like to thank and extend our gratitude to Dr. Richard Tobo, sir. Thank you for assisting, and thank you for being present here today. Thank you so much, sir.
Thank you all, and stay safe. Thank you.
Thank you, sir. Thank you, sir. So with this, I would now like to introduce our next speaker, Mr. Adnan Ahmed. Mr. Adnan Ahmed has over 32 years of industry experience across sectors and continents. He began his career with ICI, where he worked in a variety of manufacturing, supply chain, and business roles across India. Mr. Adnan joined Clarion from BP, where he held various global and leadership roles, which demonstrated success in transformational leadership and regional supply chain management. He worked in the UK with the responsibility for Europe and Africa, and in Singapore with responsibility for Asia and Pacific regions. He also served on the board of Castrol India Limited. Mr. Adnan holds a master's degree in chemical engineering from Queen's University, Canada. He received a National Energy Conservation Award from the Indian Prime Minister Dr. Manmohan Singh in 2004. He has also been conferred with the Helios Award for Human Energy by Lord Brown, the erstwhile Chief Executive of BP plc, for leading transformational change in road safety for Castrol India. We are extremely glad to welcome you for today's session, sir. We are certain your talk would enlighten us and shine a path for us to follow. I request the participants to kindly ask relevant questions in the comment section of YouTube, which will be passed on to the speaker by our team. Sir, you may please begin your talk.
Yeah, thank you. I need your help actually. I want to share my screen. How do I do that? How do I share a presentation?
Hello, sir. I'm here to help.
Yeah.
Now, first of all, in the right bottom, there is a button. There's an option as present now.
Yeah.
So before doing that, can you confirm whether your presentation is open in the background?
Yeah.
Perfect. So now click on the present now. Click on the present now. When you click on present now, there will be a couple of options. Select a window.
Select a window, is it? Okay.
Yeah, select a window.
Yeah. All right.
And then click on your presentation. You might see your presentation there, and then hit share.
Can you see the presentation?
It might be loading, I think so. Yes, it is loading now. Just a second, sir. Yeah, perfect. Yes. I think it is your first slide. Yes, we are good. Please continue, sir. Yes, make it full screen, sir. Make it full screen, sir. Yes.
Yeah.
Thank you. Continue, sir.
All right. So, real pleasure for me to be here today. I'm absolutely delighted to be able to talk to all of you. Let me just start off by so firstly, thank you for inviting me. And as you would have heard in the introduction, I'm an engineer, chemical engineer, and not a chemist. So when I try and make an attempt to start talking chemistry, it always makes me nervous. But I'm going to give it an attempt anyway. I should have probably followed what Mukundan did and brought along a scientist with me, but I didn't do that. I thought I'd be brave, but let me try. So, but I guess, when you talk about sustainability in business, that's now become a universal language. So hopefully there should be no problem there. What I'm going to do is I'm going to talk to you. I've broken up my talk into 3 sections. The first one is more generic stuff, and it's about the role of sustainability and so on in Clariant. I'll then talk a little bit about waste to value innovations, which are unique to India because we generated them. We developed these innovations in India at our innovation center here in Mumbai. And then the third one is something that should interest all of you as it's really relevant to India. And this is especially the north. And I'm sitting in New Delhi today. And when I look out of the window, it's just awful. It's so polluted. And, a lot of that is coming from stubble burning from our farmers. And what I'm going to be talking to you about is that we have a solution for that. So it's really exciting. And I hope you enjoy that. So let me start. But first, a couple of slides about what Clariant is all about. It's $4.4 billion company now. We used to be 6.5 billion, and we sold $1.5 billion last year. One of our businesses. There's another pigments business which is not included here, which is about $1 billion. We've not included it because it's called a discontinued business. We've talked about selling it globally, including in India, and this is the continuing operations. And we have about 17,000 employees across the globe. And if you look at our sales, Asia Pacific is very big for us. It's just second after Europe. China is very big. India is quite significant as well. So overall, we have a good presence in the East. And there are 3 business areas that we operate in: care chemicals, catalysis, and natural resources. Okay, so some of the stuff that I'm going to be talking to you about today is in care chemicals, and some of it is it's put under catalysis, and I'll tell you why. You might wonder why it is, but I'll tell you when I come to that. Okay, so that's what I wanted to talk to you about. Just tell you about Clariant. Strong presence in India, pigments business, very strong catalyst business, care chemicals business, and currently we have 5-6 manufacturing sites across the country in India. When we sold the mass batch business, we had 9. All right, so let's just get down to the subject of green solutions from Clariant. And as I said, three parts to it. First, the generic stuff, sustainability and innovation. In Clariant, we see these two as interlinked. And as an industry, we believe that we really have to act responsibly. Very important, and I think Mukundan was talking about that as well. Looking at profits and the environment and society all at the same time. They are not exclusive at all. They're not mutually exclusive. We can also see consumers and customers seeking value, more and more value in green solutions. This was not there in the past, but it's getting to be there more and more now and helping our top line growth when we can provide those solutions. And finally, partnering with customers, we're confident that we can come out with better solutions for markets across the globe. And we do a lot of that in India as well. The strategy in Clarion, which has been around for a while, it's been consistent for some years, looks a little bit like what you see on your screen. And sustainability is integrated into our brand values and in the company strategy. So Clarion has clearly declared the objective to be the global leader in specialty chemicals and a reliable and trustworthy partner to all our stakeholders. So we create value through appreciating the needs of our customers to start with, by providing competitive and innovative solutions, the environment by acting sustainably. And I think everybody is doing that now. There's no, it's not a choice. Sustainability is absolutely a guiding principle at Clariant, and it's well anchored in our strategy, as you can see here. And then, of course, there's the triple bottom line of sustainability, which is people, planet, and performance. And I think I heard that a little bit from part of it from Mukundan as well. And it's integrated into our brand values. In 2014, sustainability was added as one of the 5 strategic pillars for Clariant, and you can see it there now, adding value with sustainability. It's a strong external and internal signal that sustainability is integrated into the way we operate, and it drives us continuously to improve our operational sustainability and identifies business strategies to provide value-adding solutions, okay, with great economic and environmental social performance. So now I'm going to move on to talking to you about some green solutions, some options. So Clariant has developed a number of solutions in all the different areas that we operate in, and it's actually created a niche for itself on where we are today. And that's what I'm going to start talking to you about. So let's start with sustainability driven innovation. And this is something that's come out of our laboratories in Airoli, in Mumbai. So we have a global technology center there. So we've got over 30 scientists who are servicing global projects. Most of what they do is for the globe, not just for India. And what we're going to talk to you about for a minute here is waste, taking waste and converting that into value. And I think Dietmar also talked about that from BSF earlier today. I enjoyed listening to him, actually. I always enjoy listening to him. He's a great speaker. So what I'm going to talk to you about very briefly is where we take crude rice bran residue, and with technology that we've developed here, we convert that into a product which is a green ester quartz or a bran wax. And I will talk a little bit more about what these two things are. So the important thing is that these are non-food competing feedstock. So we're not competing with food. And the ester quart is basically giving us, it gives us a lot of benefits. So this Preppergen Green is an ester quart product in our portfolio, like we have many of them for fabric softeners. So some of these are based on animal origin, like tallow fatty acids and so on, and some on palm fatty acids globally. That's what I'm talking about globally. But because of deforestation caused by palm tree plantation, now there's more and more awareness of this, and people are talking about moving away from this and going towards certified palm oil. Customers don't want; they're looking for non-palm oil solutions, non-edible based products, and because of that, we've looked at liquid ester quartz, which we can make without edible oils, like cottonseed oil and so on. And usually when you make it with cottonseed, the quality is not as good. So therefore you come back to the options that we've developed. And rice bran is a byproduct generated in polishing of rice. The feedstock is renewable, and it's a product from the agriculture in India that does not cause deforestation, and it can be considered suitable and non-edible. So it makes it the perfect material for us. Another factor considered for selecting rice bran residue is its commercial availability in lots of quantity, in a lot of quantity, especially in India. And we convert this into this product, which I just told you about, the green ester quartz or Lycocare RBW, rice bran wax. So here what does it do? It gives us, it gives us great environmental benefits, and you can see that right in front on the screen. So being a liquid, what it does is it's easy to handle, and it's easy to transport, easy to process. It's energy saving for the customer as well because of its cold processability. And the performance is equivalent to other solid ester quartz. And the solid ester quartz require further processing. You need to melt it and mix it, and you need energy and so on, which you don't need in a liquid. So that's the advantage. Some companies are already providing liquid ester quartz that are produced from special raw materials like cottonseed or soybean oil. And our product is sourced from non-edible raw materials. So there's no rice bran residue-based ester quartz in the market other than ours. And for solid ester quartz, the product has to be melted, as I just told you, to be mixed with water. So, this can be mixed in ambient conditions. So that's one big advantage. So when you look at it, this is what the process looks like. You can see that the rice grain has got, different parts to it. So you've got the hull on the outside and the white rice on the inside, and rice bran is in the middle. And that's what we take out. Some of that, the crude rice bran, is converted to crude rice bran oil. Some of it goes into edible rice bran. But what is left behind is waxy kind of a material, and that's the product that we use for rice bran wax. So as I keep saying, it does not compete with the food chain. Okay, and that's an important thing to understand. So this was developed in our labs right here in India. And its use, you can see in various areas. It's used as a lubricant. It's used mainly in plastic processing. So, it has various applications. So it's quite a winning product. So what I'm going to now talk to you about, so that was just like a starter to get you started on understanding some of the green technologies that we have. But what I'm going to talk to you now is a really big opportunity for India. This is a product that I'm really excited about. And this is, to do with too much carbon in the air. So we have a business unit called Advanced Biofuels, and we are looking at solutions for pollution that you're finding in many parts of the world, especially in the northern part of India. And the technology I'm going to talk to you about is something we've branded as Sun Liquid. It's a clean, high quality, and carbon negative lignocellulosic platform. Very difficult to say that, but when I share the process with you, it's very exciting. You'll see that. So why do we need to do that? There's a lot of focus now on lower emissions from transport, right? And that's required urgently for reaching climate goals. So this is slightly different from the goals that I'm talking to you about, which is in India, which is the stubble burning that you have in northern India, right? So that's one problem statement. Another problem statement is that you're looking for lower emissions from transport. That's another problem statement, right? And that's coming largely from fossil fuels. 24% globally of greenhouse gases is coming through the transportation transportation sector. And there are many solutions that are being talked about to deal with that. One of them is change the vehicle technology and get into electrical vehicles. And we heard some of the speakers talk about that earlier. But that is, it's a high cost because you're changing transport, and you're going to focus on electricity. Country like ours, where is the electricity coming from? If it's coming from coal, how is that better than fuel? So those are the kind of questions that you'd have to ask. But that's what's being looked at. There's also this energy infrastructure that you're looking at for renewables. Again, lots of investment, big capex outlay, and so on. Then there's a shift in transportation, maybe less air travel and more sea travel or whatever when you're transporting goods and so on. But the fourth section is about looking at advanced biofuels. And this, I think, is really, really exciting. And if you look at India, we have a huge bill of imports as well, based on the crude that we import. So imagine if we could substitute that with a technology that can convert waste into, say, bioethanol, which can then go to dilute your, or to be mixed with petrol, and then that used to fuel your vehicles. So you're going to reduce the outflow of forex, and at the same time you're going to be using waste to convert that into fuel, and you will reduce the greenhouse gases that are being released and the stubble burning and the pollutants in northern India. So look at the number of benefits that you can get from this technology. I think it's a very exciting opportunity. So what exactly is it? So there's a number of benefits you see. Firstly, it can be carbon negative, and it's amongst the highest total life cycle reduction in greenhouse gas emissions. So I will share this with you a little bit more in detail when I talk about the technology, but this is a very exciting part of it. The technology is validated, so this is not something that's at a lab scale. We are operating a plant right now. It's called, we call it a pre-commissioning plant, and it operates at 1,000 tons per year. So it's producing very high quality bioethanol, 2G bioethanol, second gen, and it's coming from straw. It comes from wheat straw, rice straw. You can try various different types of maize, barley, wheat, and sugar. So many different raw materials have been tried, and it's worked brilliantly in all of them. It's unrivaled in use, because what we feel is that it provides a superior energy density. Now, this is being challenged because there are probably some others that have that are beginning to show equally good energy density, but the point is that the energy density that we're getting from our product is extremely good. So I think that's something to keep in mind. There's the low carbon abatement cost. So again, very important for a green solution, and it gives you enhanced energy security. So especially for us, when you're not looking at importing fossil fuels or crude from other parts of the world, you can become more self-dependent, and it's coming from your farmers. Just managing the logistics of collecting the stubble and bringing it to our plants, and it can also provide you green jobs, managing the entire supply chain of the stubble. So when I show you the process, you'll understand that a little bit more. So let's look at Sun Liquid, and this is our solution to decarbonize mobility. Here's the process. It's really exciting. If I can just share with you, I'm going to pull out some of my notes to see it. All right. So as I've said, I'm really excited about the possibilities that we can get from this technology as it opens up new solutions for us for a problem that we've been seeing for many years. Process starts with 4 to 5 tons of cereal straw, which can produce 1 ton of 2G ethanol, bioethanol. Right? So you start with 4 to 5 tons, and this comes from 1 hectare. That's just about 2.5 acres, just under 2.5 acres of farmland. So if you look at a plant of 50,000 KL, 50,000 or 100,000 per annum, then what we're actually looking at is dealing with anywhere from 1 lakh acres, 2 lakh acres of farmland, which is quite significant, right? From one plant. And if the stubble is annual, then you've just got to be careful that you have to manage the entire supply chain, because the stubble might just be generated over a 2-week, 3-week period in the year, but it has to be supplied into the plant on a daily basis. So you need to manage those logistics. And in many countries, the government is stepping in to manage that logistics. It pays the farmers to take away their stubble. It needs to store it somewhere, and then it feeds it to these plants, right? So it creates a whole supply chain of its own, creates some jobs, but at the end of the day, it's well worth it. So let's look at how it works. It starts with a process of pre-treatment, which is chemical-free. So it's really important to understand that this is chemical-free. So it's a thermal pre-treatment. And this pre-treatment, because it's chemical-free, gives you many benefits as you go downstream. Because when you produce the lignin, when you produce the vinasse, or the CO2, whatever, you don't have it. It's not contaminated with chemicals. You don't have to clean it again. So it just allows you to use some of the byproducts more easier. After pre-treatment, we move to the next stage. And in this stage, it's a really important stage for our technology because this is where we do not need an external source of enzyme. The enzyme is produced in situ, as you can see here in a separate vessel. Starter culture is used, which is provided by Clarion, but that is all. So a lot of other technologies which are also trying to work this out, you have to provide the enzyme externally. So every time you have to buy that enzyme and provide it. Whereas here, it is produced in-house. It comes in situ. So that's a big step, and it's copyrighted there. It's patented rather. And then there is the saccharification process, and this is a really efficient process. The way the saccharification works here, it's highly efficient and produces a high yield output of both C5 and C6 sugars. And since pre-treatment, I told you, was chemical free, the lignin can be used directly to act as a fuel for the process energy requirements, and it can actually be self-sufficient for this process, which is again very exciting. Right? And finally, so we go to the next stage where you go through the fermentation process. And this fermentation can ferment both C5 and C6 sugars. So you again have processes which really focus on C6 sugars. You can do both C5 and C6, and it delivers significantly more ethanol as well. And from here, you get an output of carbon dioxide. So I know it's a bit of a cost, but you can capture that carbon dioxide and you can take it off site and use it for various different uses. And you also and it's a high purity product. You then go through your purification stage, which is again, it's been optimized. A lot of work has been done to get the right purification here, and the ethanol that we get, high quality ethanol, and you get vinasse, and the vinasse can again be used as a biofertilizer. Now, unfortunately, in India, we don't have permission to do that. But in Europe, it's used as a fertilizer, and they've got a license to be able to do that. So for us, the next stage for us is to go to the Department of Agriculture and apply for approval to use this vinasse as a biofertilizer. It will take a couple of years to get that approval. Until then, all you can do is use it as an energy feedstock, so you can burn it, right? And it comes out as a syrupy, slurpy kind of a thing with almost 60% solids or more. So it's quite a valuable byproduct here again. And finally, we end up with the 2G bioethanol, which is really fantastic. So if you look at the process, the pre-treatment has an IP. The enzyme that I talked to you about and how we generate the enzyme production has an IP. The saccharification is also patented, and as well as the fermentation and the fermentation organism. So there's a lot of patents here because there's been several years of research has gone into creating this this beautiful process, and then we've been running this process for over 3 years now. Sort of a partnership with somebody that we're talking to in India to look at an opportunity to put up something in India as well. But more about that in maybe a few months, I think, before we can announce something there. So if we look at the benefits, why am I so excited about this project? To start with, it's fully integrated. You start with feedstock, and then you come out with ethanol. So it's just a nicely it generates the enzymes in situ. So it's a fully integrated process, and I'll show you how even the energy is all generated from within, and it's fully validated because we've been running it for more than 7 years now. Sorry, I said 3 or 4 years. It's 7 years. the pre-commercial plant. I visited it in December last year. It still looks spanking new, but it runs every day, running extremely well in Germany. It's very flexible in terms of the feedstock. So the enzyme changes, but the feedstock can be from various different sources. It can be from sugar, can be from wheat, can be from maize or rice or whatever. It's patented throughout the process, very strong IP, and it's taken over a decade to generate this from our in-house R&D. So we are very proud of it. The business case is actually quite attractive. The operating costs are not that high against our competitors, and the capex can also be relatively lower than what we are aware of from our competitors in this process. And then it gives you clean, high quality byproducts, lignin, vinasse, and carbon dioxide. One of the reasons is that the pre-treatment is chemical free. The process design is flexible, and we're going to be exploiting that a little bit when we come to India. And we can train personnel at a pre-commercial plant in Germany. This is very, very important, because we have this pre-commercial plant, which is ours. We can actually take customers there. We can actually get them there to understand the technology, and we can train them up on the technology in a live operating plant. So it's not theoretical. It's actually a live operating plant. And then, of course, we have a very strong global presence, which helps us as well, right? So here, I'm just sharing with you the circular economy, a really outstanding example of that. So everything, all the different components here either minimize resources or ensure that they're used optimally. So, and they're used sustainably. Agricultural waste is utilized instead of being thrown away. No fossil resources are required right through the process. And as I explained to you earlier, it's energy self-sufficient. So, you can conserve energy there as well. Ethanol produced saves around 95% greenhouse gases compared to gasoline. That is huge. That is really huge. And the use of the byproduct, like I mentioned to you, vinasse, can be used as a fertilizer. Unfortunately, in India, we don't have that approval, but hopefully we should get that. And then water extracted from the vinasse is fed back into the process cycle. So it's really an integrated, circular process. Okay. And I'm coming to the end of my presentation, but there is also more that we can do with sunliquid. It's not just the creation of the bioethanol, but you can do stuff. You can use a biorefinery to process from sunliquid. You can go to downstream products, from biodiesel, alcohols, ethylene oxide, lots of different things that you can do with the ethanol. And then, of course, you can use it as fuels. You can use it in different industries. So it can open up a whole new economy. It's very, very, the potential is very, very exciting. The thing is that we've got to start using it. So right now we have 4 licenses across the globe with different partners, and we're really keen to bring this to India. And once we do that, and I'm confident we will, I think it can do a lot of good for us in India, both in terms of helping us on foreign exchange savings from crude imports, and also in improving the environment. And hopefully, if we can get approval for vinasse being used as fertilizer as well, then we can exploit the fact that it's a circular economy. And that's something that I'd really be keen to do. So in a nutshell, that's what I wanted to share with you, if you're okay with that. And, happy to answer any questions.
Thank you, sir.
I hope you heard me, right?
Yes, sir.
Okay.
Thank you so much, sir. It was quite an interesting and engaging talk, and we hope to take up on your insights. We would also like to express our gratitude to Mr. Tej Dialani and Ms. Prerna Satpal from Clarion to have joined us during Mr. Adnan's talk. Thank you, ma'am. Thank you, sir. Prakash, sir?
Yes. Good afternoon, sir. Thank you once again for the nice lecture. It was very interesting to learn about these new things. I have some questions to ask. you permit. My first question is, sir, everyone talks about biomass, and earlier it was 1G biomass, and then we had the food versus fuel debate, and then it was 2G biomass where we had the lignocellulosic biomass, and then people said it takes up a lot of land, and then now we have 3G biomass, for example, algae and so on. So what are your comments about this 3G biomass? Do you see it coming up in a big way in the near future?
So, I have to be honest with you and tell you that I don't really know much about the 3G biomass. I know that for us, we are very focused on 2G biomass, and I don't think it's not competing with food chain. It's not competing with land for anything else. So, the technology that we are talking about here is clearly taking waste and converting that into something of value. But on 3G, I really don't know. So I would be the wrong person to try and answer that.
Okay. So you have told us about a circular economy, and
Yes.
today we live in a hydrocarbon economy, and then we do hear about a hydrogen economy or a methanol economy, and so on. So, do you foresee all these economies coming into being in India in the near future? Is it that the day is not far?
Yes. So I think yes, the answer to that is yes. But unfortunately, I think I caught the last bit of the last talk where Mr. Mukundan was talking. I think he was talking about PCPR, right? He was talking about, yeah, and that is a part of the chemical strategy or policy, chemical policy of the government of India. I think the issue is that as a government, the chemical industry has always been neglected. Now, I don't want to be sitting here whinging, but the reality is we have a very clear policy for automotive. We have policy for banking. We have policy even for IT. We have policy for all different sections. But the chemical area was always neglected, and therefore there is no clear guidance. There's no clear direction. It's just all the different players in the chemical industry who are doing their best. And this is a fantastic industry because, the size of the industry is not small. It's $150 billion in India, going up to $300 billion in the next 3 to 4 years. COVID or no COVID, it will go to that size. Specialty chemicals is also big. So, we're really crying out for some sort of policy direction from the government of India, which will help us accelerate some of these things. So when we're talking about circular economy, whether it's a hydrogen economy or whatever it is that you talked about, methanol or whatever, you do need some sort of logistical support. Just the example I've given you today, this is not something that a private player can just come and set up and start working. How are you going to collect the stubble from large tracts of land? How are you going to engage with lots of little farmers? Because you don't have big farms in India, unlike in Europe or in Brazil or China, where you can have big land masses and you can deal with one or two people and get the job done. Here you have to deal with lots, so you need government support. So there has to be a little bit of support coming in. Now this government has definitely been talking about that, and they are trying to push this technology which I just shared with you. But talking about it is not enough. We need more support. So your question, is it going to come to India? Absolutely. The question is when. And everything takes a long time to come to India. And it should not be, because I think there's a crying need. I'm sitting here in Delhi today, and you can't breathe when you step outside. And this is, you can't, every year it's the same. It was like this last year, it was like this 2 years ago. Only difference is this year you have this and COVID, so we need a solution. And in our own little way, we're trying to start up with getting one license, getting it to work, which will take a couple of years, and then maybe go to another license, a third license, fourth license, and then spread it out. But that will take a long time. But that's what we're trying to do right now. And I'm sure there are a lot of other companies also trying, whether it's with the hydrogen economy or whatever. But these are not they're not easy, and they do require investment and patience. So it takes time.
Sir, you mentioned about the policy of the government with respect to chemicals, and we hear that the government is striving to reduce the import of quite a few chemicals, so that we become self dependent, on that. Can you name such a few platform chemicals or important chemicals that we as a country should focus upon? And if you could tell us how green technology can help us in this drive.
So two different questions you asked, and in some cases they merge, in some cases they don't merge. Okay, so let me start with something that doesn't merge. We are one of the we have a lot of titanium dioxide, rutile. Yeah, but to make it useful, we sell it to China. They process it, and then we buy high grade dioxide in India. Right? Classic example. We've been doing this for years. One of the best industries, fastest growing industries in India is the paints industry. And one of the biggest growth areas for the paints industry for the last 2 decades has been exterior paints. When you drive around India, you'll see most of India hasn't been painted, right? So this is going to get painted over a period of time. So huge opportunity, but it's lying there. Nobody will do it, anything about it, till there is some incentive to do it. See, at the end of the day, companies are not going to do stuff unless it's profitable, right? So that's one part of it. That's where government policy comes in, because they can help you. Because we are not asking for dole outs. What we're saying is help us become profitable. Now let's see, why am I not profitable? If I want to set up a plant in China, China will tell me, come and set it up. And I take my engineering technology and I build the plant. So the expertise I have, I know how to make my chemical. So I build the plant for that chemical and I put it up. They call me to a chemical park. I build my plant. Then they give me hot oil, they give me steam, they give me compressed air, they give me electricity, they give me beautiful roads coming in, they give me a logistics park. I'm ready to go, and my stuff moves out and goes all over the world. Now I come to India. So I want to build the same plant. First thing I will do, I'll buy a generator because there's no electricity. First thing, you go to any India, you see these gigantic generators. You don't have electricity. And then you have to build a big effluent treatment plant of your own. You have to, so it becomes, and then, it's easier for me to get raw material, to buy products from Dubai into Mumbai, then send it from Chennai to Mumbai. Yeah. Because the logistics costs are so high. So in India, we grapple with a lot of things, but at the end of the day, we are still exporting. I have a plant in Kadalur, which exports 90% all over the world. And we make outstanding product. It's competitive. Imagine if I had good logistics, I could double, triple, quadruple my output. So that's the one challenge. Your next question was, about, it was about green technology, right? As well, about circular. So, on that front also, I told you that we need some logistical support. Now, whether we get it or not, we are going to try. We're going to try and do something. But if we could get, some support as well, I mean, the government has been talking about self-sufficiency. And if we can use 2G bioethanol, it can replace, say, 10% of crude of petrol. Let's say you blend it 10% or even 15 or 20%. Imagine that 15 to 20% petrol, how much crude it requires, which you're importing, and the foreign exchange that you're spending. You could save all that, because instead of that foreign exchange, I'm actually paying my farmer for waste. I'm cleaning up the environment and I'm getting a cleaner fuel to use. So all these things can come together. Now, why is it not happening? Because it sounds so simple, right? Because there are so many competing directions in which the government has to operate. It's really complex. And as I always said to you, as we always say in the chemical industry, it's never been a priority. And part of it is the fault of the chemical industry. I don't think we have adequately lobbied with the government to let them understand what a big employer we are, what a big manufacturer we are, and how much taxes we bring, and how much value you bring into India. So, I'm talking to a bunch of technical kids, engineers and scientists and so on. So you understand that any economy that is based on manufacturing will generate wealth for its country. But if you're not based on manufacturing and only on services, then it's very limited, right? It's a small group of people that will benefit, whether it's banking, IT, all these things, great stuff. But you cannot run a full country like ours just on banking and IT and hospitality and so on. You need heavy duty manufacturing and lots of it. And this government, the previous governments, they all have understood this. And they're all trying to bring more and more manufacturing into India, but they somehow skip chemicals. They look at mobile phones, they look at automotives, they look at various other things. For some reason, chemicals is not, I don't know, it's not glamorous maybe. So it's got skipped. And as I said, it's part of us in the chemical industry. We need to influence the government a lot more to understand they must pay more attention to us as an industry. I mean, the people in the room here, all of you studied engineering, chemical engineering, chemistry, whatever, and it's such a fantastic field with so many opportunities. And chemistry is really good. Chemistry is good, and chemicals are good. But if we don't treat them with respect and we don't treat them properly, they can be bad. They can be poisonous. They can be hazardous. But what we are trained to do is take the hazard from chemicals and manage that risk. That's what we are paid to do. That's what we are trained to do, and we can do it. And India has an outstanding pool of scientists, chemists, huge numbers of chemists. So imagine if we could really, if we could really accelerate the chemical industry in India. I think it's a huge opportunity, and we have to do it responsibly, not polluting the waters and the soil and so on. And it can be done. It can be done. Long answer to your short question.
Thank you for the nice words of wisdom. In my turn, let me summarize about our program. So see, this Master of Technology in Green Technology program started in 2009. Our first Vice Chancellor, Professor G.D. Yadav, was instrumental in starting this Center for Green Technology. And since 2010, we have been having students for the Masters as well as the doctoral program in Green Technology. So this MTech in Green Technology, every year we admit about 30 students.
Okay.
And it's a 2-year program, 4 semesters. The first 2 semesters, our students, they have papers. So they study various subjects, and we have ensured that the syllabus covers all the important subjects in today's times related to green technology, green chemistry, nanotechnology, biotechnology, and of course the basic things on chemical engineering. So typically in the 3rd semester, our students go to the industry for some internship. Unfortunately, because of this pandemic, this current batch couldn't go, but up till now, our students have benefited from that. And in addition, they also study process safety. So we have a course, it's called a certificate course on chemical safety and risk management. So they study all aspects of safety. And this is how we try to prepare them for the industry. We give them the best possible training. And in the 4th semester, they focus on their research work. So we have a very enthusiastic group of teachers as well as students. We do work in many areas, for example, chemical engineering or pharmacy or chemistry or biotechnology. It's a mix of all these teachers. And we all perform our research in our own fields, and these students help us. And that's how it goes. So thank you. We are so happy that you agreed to come here and you shared your valuable thoughts on that. Are there any other questions for the guest?
Yes, sir. Yes, sir. We have actually. There's one. This is my personal question, which I would like to ask to Adnan, sir.
Yeah, please.
So we've been discussing about the situation of Delhi and how Delhi is facing, the name of one of the pollutest city of the whole world, right? Now, when we discuss that, what are the major reasons behind it? First, being as a capital, there are a lot of vehicles going on. So yes, the government over there is somehow trying to arrange, even odd roads and everything, trying to reduce the pollutions. Problem is that, as you also know, that the main reason is stubble burning, which is not in Delhi but in Haryana and other sites. Now, as you said that in foreign countries there are in acres and acres of places where they can easily collect it. But same thing when we talk about here, it is something not easy to do. Meanwhile, if you talk about farmland, it might be not directly compared to USA or UK farms, which is a lot big, but it is somehow so big, and maybe not big, but actually collaborated. So if government wants to, then they can directly reach to villages. And the best part is that when you talk about stubbles, say maybe wheat or rice, they the whole village plants at the same time, so they can collect all the stubbles at the same time and cheaply. So do you think that what could be the possible ways? Maybe I'm not sure whether how the proper answer will be, because this has to be basically with the government and the policymakers and everyone. But what are your ways? If you would like to do, then what would be your ways to make sure that we collect all the stubble, and how maybe we can plant micro plants like maybe not all at the same place, but distributed ones, so it will be faster to give the solutions as well as give the profit to the nearby villagers. So there could be a lot of other variables and profit ways by which we can do it. What do you think regarding this?
So firstly, what is your name?
I'm Nitish, sir. I'm master student in green technology.
Okay, Nitish.
Yes, sir.
Okay, so Nitish, partially you actually answered the question very nicely, but let me just say, the first thing that you would look at, if you're just, let's look at Delhi as a problem statement, right? So when you're looking for a solution, it's got to be a holistic solution and looking at various, because if you just solve the stubble burning, that's only one part of it. That's about maybe 30% of the problem, right?
Yeah.
But it needs to be resolved. When you look at Delhi, there are too many cars, so you do odd, even, odd. These are tactical solutions which will solve the problem this week, but not next year or the
Yes.
year after, right? So people still have to get from point to A to point B. People still have to commute, right? So either we need fuels that are much cleaner, right? Or we need a better public transport. So you've got all this metro and things. So you need to generate less pollution in transportation. If you
Yes.
bring in more bioethanol, if your petrol is 20%, maybe even 25% ethanol, then the greenhouse gases that you generate comes down, right? The particulate
Yeah.
matter that's coming out comes down. So that is one thing that you could. Meanwhile, when you're coming to the farms, the issue is that your stubble may be collected in November, but you need to feed it to the plant all through the year, 12 months. You can't just
Yeah.
run the month, you can't just produce everything in 1 month, no? So you need to collect it, it needs to be warehoused and stored, and then it needs to be supplied to these plants. And like you said, you can have satellite plants, but the capex is not terribly small. It's not very
Yeah.
high, but it's not terribly small either. So your plant has to be, one, close to where you can get the stubble. Secondly, it has to be close to oil um, companies like HPCL, BPCL, IOC, because you have to supply to them so they can blend it.
Yeah.
So, if you go far away, then you'll have transportation costs and so on. So, for example, Bhatinda is a perfect place. You've got HPCL there, it's a big farming area. So there was a plan to put something up in Bhatinda. But you need a policy. You need a policy, and it has to be well thought through. It has to look at a number of things, and over a period of 5 years, you can crack it. That's what China has done. Remember when they had the Olympics, you couldn't breathe in China, and you go and
Hmm.
see now you get blue skies in Shanghai. So I'm longing to see blue skies in Delhi. I'd love to see blue skies, but you don't see them now. So I
Yes.
think you just need a more cohesive policy. It has to look at all these. The solutions are all out there. It's the execution that has to be done really well, and I think it can solve a lot of our problems.
Yes. Actually, one more technical question which I want to ask. So, a couple of years ago, when I was working on lignocellulose waste, so I realized that over there I realized problem with I have a stubble. Okay, maybe any lignocellulose mark, maybe rice bran or something. So the first step is that they put it inside say high pressure chamber, and then they set and expand it. So it will release the lignocellulose and the hemicellulose and side materials. But the problem is that that is highly energy intensive process, and maybe not that safe, but actually the energy intensive process. Which, and there are a lot of other similar things which are energy intensive process, which brings down the overall economy to a certain scale, which makes it very hard to implement. So, what do you think? What kind of technological and advances that we need to make it, say, more profitable and easier to make?
So the process that we have called Sunliquid has already proven a process by which the waste that is generated can be used as fuel, and it is enough to make that whole process self-sufficient. So actually, you don't need any outside energy. So even if it's energy intensive, it feeds itself. So it's generating waste which can then be used as fuel and provides it energy. So actually, from my point of view, that's okay. So if you are requiring a high energy thermal treatment at the start of the process, at the end of the day you're also getting out waste which is chemical free, so you don't need to clean it, and you can use it straight away as fuel. So for me, that's fine. I don't think it's an issue.
Well, similar to that,
I don't think it's a problem.
technical question. Similar to that, there is a technical question. So, like you said, sir, that we can generate the fuel from the process, which is obviously very the best thing we can do, and then we can utilize this thing in the process, right? Similar thing as has been implemented in various plastic conversion to biofuels, correct? So, while I was reading that, there was such a question, which is generation of entropy, which I think very common. I mean, it is easy to understand that whatever we do, doesn't matter, we go to A to B or generate biofuel from the waste or biofuel from lignous cellulose, there must be generation of entropy. So, how would you think? Because yes, we are reusing the product in our system to our as a feedstock or to as an energy energy providing material, but indeed we are generating entropy. So, what would you like to comment on it? Because in generating entropy means what? Generating carbon footprint, generating, say, heat loss, anything. This might be minor, but I think when we take it like regression of it, this turn out to be like a major thing. So, what would you like to comment on it, sir?
So now you're getting to a part well beyond my capabilities. So I think Nitish, you are probably better placed to answer that. I really can't say. So, but I mean, if you want, you can get in touch with our scientists, and I'm sure they can have a lovely conversation with you on entropy.
Okay,
So,
okay.
sorry about that.
If you want, then I
Yeah.
could give a short explanation. What I mean by entropy is that so whenever we do
No, I
something,
understand. I understand. But what I'm saying is, I can't add value to what you already know in that area. Yeah.
I understand. Listen, I think that was a great talk. I'll hand it to our head event coordinator, Pritika Margeson. Please continue.
Thank you.
Yes, thank you, sir. Thank you so much for patiently answering all the questions and for giving such a wonderful talk. It was really engaging, and we hope to connect with you in future. And thank you, sir. With this, we conclude our session. And I take immense pleasure in thanking our eminent speakers, Dr. Deepma Hublin, Mr. Ramakrishnan Mukundan, and Mr. Adnan Ahmed for such an informative talk and for contributing their valuable time. I would also like to thank Professor Vaidya sir for supporting and guiding us throughout the events. Thank you, sir. Participants will be provided with a certificate of participation on successful submission of the feedback form, the link for which has been shared in the YouTube live chat box. E-certificates will be shared to the participants within 7 working days via email. I also thank all the participants who connected with us today and for being such a delightful audience. Lastly, I would like to thank the backend team of IPGT for managing the program. For any queries, participants can write us at ict.greentechnology@gmail.com, which can also be seen on the screen. Thank you and have an amazing day ahead. Thank you so much. Thank you so much, sir.
Thank you. Bye-bye.
Yeah. Bye.
Thank you, thank you, thank you. Guys, I hope if you are watching this session via YouTube Live, I would request to fill the feedback form as soon as possible. We would like to end the event here, but the feedback form will be on for next 1 hour. Currently, it's 4:40, and it will be turned on for say 5:40 or 6 o'clock. Beyond that, we will be closing the feedback, and the students who have fill the feedback form will only will receive the certificates. So thank you so much. It has been a great time to have you, and have a good day. Bye bye.
Thank you, everyone. Thanks for
Bye-bye.
connecting. Thank you, sir. Thank you.
Bye-bye.
Bye, sir. Bye. Thank you.
Bye, sir.